So these 7 job candidates will be evaluated for 4 human resource or by 4 human resource officers, RST. Each applicant will be evaluated by exactly 1 officer. What's that telling us? Everyone goes once, right? And each officer will evaluate at least 1 application. So that's really crucial. If every officer does at least 1, then you now know that these should probably be our groups, and each group is going to have at least 1 person in it, right? So we have RSTU, RSTU, and I'm going to have 1, 2, 3, 4, so 1 in each group. Are you cool with that? I was hesitating a little bit because I wasn't sure if I should make them my groups or do this some other way, but okay. Grant application must be evaluated by you. Okay. Grant goes there. Then it says F's application must be by the same officer who evaluates L. So F and L have to be in the same group, but we don't necessarily know where. Neither H nor M can be evaluated by by the same one who does I. So M, let's see here. Well, M and I is not going to happen, and then H and I is not going to happen, right? Okay. Then it says the officer who evaluates K cannot evaluate any other applicants. So K is all by itself. What can you infer about K right now?
It's not in U or S.
Okay, at this point it's not in U. We don't know about S yet, but you're absolutely right. No, that's okay. No, that's good. You have a sense for these games, right? Spidey sense. Smith must evaluate more of the applicants than T. So if Smith is greater than T, then we know that T has at least 1. We know that S has at least 2. But here's something I would kind of want to consider at this point. Could T have 2? S would then have 3 at least, right? So that's 1, 2, 3, 4, 5, 6, 7. So it works. Because sometimes it doesn't work, right? You force T to have, or S to have more than T, and all of a sudden now you don't have enough slots, or you have too many slots. So T could have 2, could have 3. Now that would be going too far, right? So we know that T is 1 to 2, and we know that S is 2 to what? What's the most that 2 could have?
3.
What about 4? Could T have 4?
If T had 1.
If T had 1. Yeah, I think we could get S up to 4. So at least I don't see any reason why not, at least at this point. So S is 2 to 4, T is 1 to 2. You're absolutely right about K. K can't be in S, it can't be in U, because it would be with other things. So that means K is either in R or T, right? So I have K going back and forth between those two. Okay. All right. Inferences. Do we have any floaters, by the way? G, H, K, I, A, K, or say K, L, M. No floaters. What variable is constrained the most? Yeah, either I, maybe K, right? Because K is pretty constrained because it can't be with anyone else. So those are the 2 variables I'm probably going to be looking at the most as we make inferences. Which questions do we want to go over?
8.
8 is great.
Oh, no, actually, no, I don't want to go over 8.
Okay, it's retracted. Anyone else want to go over something?
Over 8 then.
Oh, okay. If exactly 2 of the applicants are evaluated by T. Okay, so 8, 1, 2, 3, 4. I'm going to go ahead and recreate these here because they're kind of far away. But in any case, if we have exactly 2 by T, you're going to put 2 T there. What do we know must be true?
K is not a T.
Okay, K is not here.
S has 2.
Yeah, so let's go ahead and do these one at a time. So we got K over here, and then like you're saying, S has to have at least 3, right? Because it's got to be greater than T. Okay, can we have more than 3? No, that's it, because you're going to have 5 here and then that and that. Okay, so K's there. This is all said and done. Who's left?
FL, I, H, N.
Which one? FL is a nice one because it's a big block, right? There's only two possibilities for FL. It goes here or it goes here. Can you tell me where it goes, or could it go in both?
I think it goes in S.
Why?
Because then you would have H, M, and I together.
Yes, if I put FL here, all those have to come together. That's not going to fly. So we know FL has to come here. So we can put FL here, and then what happens?
H and M, or yeah, H and M have to go in T.
H and M have to go in T so that neither one of them avoids I, or both of them avoid I, right? So I goes here, H and M goes here. Are we okay with this? Okay. What's it asking? Each of I must be true except, well, that's not surprising because there are a lot of things that must be true. Exactly 1 is R, yeah. Exactly 1 is U, yeah. F is evaluated by T. No, that's false. That's the answer.
Okay. Yeah, when I was doing this one, I just completely forgot about the S has to be more than T rule.
Ah.
So.
Okay. Yeah, that would make this a lot harder. Although in this particular question, if T has exactly 2, K has to go here. Oh, so you thought things could come over here. Is that what that was the challenge?
Mm-hmm.
Okay, that makes sense. All right, other questions we want to do together. 9. If the officer who evaluates M's application does not evaluate any other applicant. Okay, so for 9, 1, 2, 3, 4, we still have the R, S, T, U. We always have G. We always have at least 2 in S. And now they're telling us that M is all by itself.
Mm-hmm.
Do we know where M goes? Where can M not go?
S or U.
Can't go in S or U, right?
Mm-hmm.
And can it go with K?
Possibly.
Not in this particular question because M is all by itself.
Oh.
Right? That's why it's not going to go here. It's not going to go here. So M is going back and forth here,
Mm-hmm.
as is K. Right? So K was going back and forth, and now M is going back and forth.
Mm-hmm.
And in both cases, I can't put anything else here.
Right.
Right? Okay. So who do we have left? This is always the question. Who's left?
F and L.
Okay, so we have F and L. I wouldn't necessarily write them down, but we have F and L and
H
H
and I.
and I. Okay, so F and L is either going to go where or where?
S or U.
Yep, it's either going to go here or here because these columns are done, right?
Mm-hmm.
So if it goes here,
Mm-hmm.
is it possible to still deal with H and I, who can't go together?
Yeah.
Yeah, we
Just
could put
F can
one
have
here
3,
and one
yeah.
there, right? Now if I put FL here, can I still deal with H and I?
Yeah, you can split them. No.
Why not?
This has to be more than T.
Yeah, S has to have at least 2.
Mm-hmm.
And so if I put FL here,
Mm-hmm.
then all of a sudden I have to put 2 here still, but the only thing I have left is H and I.
Right.
And so they're both going to go in there. So F and L has to go here.
Okay.
And then H and I have to be split up.
Mm-hmm.
So one of them is going to go here, and the other one is going to go over here. Because they can't go in those 2.
Okay.
So whenever you have only 2 groups and 2 people who can't be together, you know they're going to be split.
See, I thought it was either equal to or more than.
Yeah, you're right.
F and T.
It's equal to or more than.
So I thought.
No,
it was okay
equal
that,
to. I'm sorry.
Yeah, so I thought
No,
it was
it's not
okay
equal
that
to have.
each had single.
Like
That's
you
how I
thought,
got it
you
wrong.
thought that this was 1, and
Mhm.
you could have 1 here.
Mhm.
Yeah. Okay, so you okay with this?
Mm-hmm.
All right. So 9. Which one of I must be true? M's application is evaluated by T. No, that doesn't have to be true because they're going back and forth. L's is by S. Yes, that is true. Actually, that's what we just figured out. Okay. Other questions?
11.
11. If F's application is evaluated by R, all right. Let me get rid of this for a half second. So, question 10. 1, 2, 3, 4. R, S, T, U. We know G is always here. We know we're going to have at least one more there. And they're telling us that F is by R, right? So F goes in here. What do we know must be true?
Else.
L's going to go in here too. Cool with that? Okay. So we'll put L here. All right. What do we now know must be true?
K has to go in T.
K has to go in T. Are you cool with that?
Why?
Because remember, K had to be by itself.
Right.
So it couldn't go here and couldn't go here. So K is going back and forth between these two places. If you have F and L and R, then K can't go in here. Otherwise, it'd be with somebody.
You're looking at 10 or 11.
We're doing an 11.
Oh,
You
yeah,
wrote
10. Okay, and so why?
Yes, so
Okay.
can't you tell? No, sorry. Yeah, it's 11.
I was so confused.
Sorry about that. Okay, 11. That's the one you were asking about, right?
Yeah, 11.
Okay.
Yep.
All right, so K has to go here to be by itself.
By itself. Okay. Okay.
Are you cool with that?
Yes.
Okay, so K goes here. So then the classic question, what's that?
H and
Who's left? Yeah? H and,
I and M.
yep, I, H, and M. And what do we know about them?
So H and M have to be together because I can't be with them.
Yeah, because if I went in either one of these, right, H would have to, or M would come here, and it's not going to
Yeah.
work. So H and M go here, and then what happens?
And I has to go under U or R.
Yeah, U or R. That's right. So I is here or here. Okay, then it says, how many of the other applications is the identity fully determined? So they told us F, right? So we don't need to worry about that. So then we just count up the rest. So we have 1, 2, 3, 4, 5.
You include G.
You include G because they never talked about it in this question. It's just part of the original rules.
Okay.
Yeah. It is a gimme, but we do have to include it because it is fully determined. All right. You feel good about that?
Yeah, I think I just misread the question. I thought it was asking about how many officers do we know are interviewing.
Oh,
someone, so I
okay.
just
As
misread.
opposed to the people. Okay. Any other questions on this game? All right.